Vielen Dank.
I'll be giving my presentation in English. I think that'll be much easier for everybody. Now, first of all, thank you very much for these kind words of introduction. Ladies and gentlemen, it's a great pleasure to be here. I'll also start out my presentation and looking back, giving you a historic view, not just for the large aircraft, but for a 100-seat aircraft, the DC-9 that entered into service in 1969, compared to a B-717 that entered into service in 1999. So the same number of passengers were in that aircraft. However, there was one major difference, and that the B-717 was only perceived to be a quarter of the original noise for the previous model. Now, this also can be seen when looking at the takeoff noise contour. So the DC-9 line you see here on the slide with the respective figure 87.9 square kilometers as compared to 717 6.4 square kilometers. So a distinct reduction in the contour, but we're not going to rest on these laurels. As the previous speakers have already alluded to, we're going to continue our efforts in trying to reduce noise further, and that will, for instance, or was, for instance, defined in what we call the Icana 2050 environmental goals, not only for CO2 emissions, but also for the NOx emissions. And we're talking about noise here. And as previously explained, for noise, we set ourselves quite an ambitious goal in that by the year 2050, we intend to reduce noise by another 65% compared to the year 2000. That's the basis of comparison, which I believe you will understand is a very ambitious goal. But as you can see when looking at the blue dots on the right-hand side, looking at the latest engines, we're actually well underway in achieving that. It's not going to be easy to achieve it by 2050. We're going to have to keep up our research efforts and cooperate with our partners in order to be able to achieve it in the end. Now, what are the sources of engine noise in a modern engine? Now, first of all, we have the fan, the rotor, that just absorbs the airflow, and the respective bypass flow is guided along the engine and that blown out to the side, and that, however, also is responsible for the greatest share of thrust. Now, the fan is then actuated, propelled by a system that is consists of a compressor, a combustor, and a turbine, and all of these components are potential sources of noise. In addition to that, you have the jet noise, so the jet stream causing noise just as well. Now, what is the source balance? So what of the sources contributes how much to the overall noise level? Overall speaking, you can say all of them contribute, and depending on whether it's a flyover, whether it's a start or a descent procedure, all of them contribute. In order to reduce noise effectively, we need to reduce noise in all of these components. So therefore, we're facing quite a complex task. Now, how do we do that in modern engines? I'm going to explain just very briefly using this model. First of all components in modern engines are no longer assessed just based on efficiency and aerodynamics and optimized according to that, but also based on noise emissions. We also need to take the other parameters into account to the detriment of some of these other parameters. So the bypass flow is to be improved. This again has a positive effect for jet noise and fuel consumption. Now, the rotor system, so the fan system that is, uses a lot of low noise design technologies, different geometries, etc., in order to achieve two different goals. One being to make sure that the noise amplitudes generated by the fan can be minimized further and further, which is what we can achieve, and then also that the number of fan blades and the geometry is shaped in a way that you have a sound field that cannot spread as much inside the engine. So therefore, we try to keep the noise inside the engine, basically. This is applied to the compressor as well as the turbine. So we call that the acoustic cutoff turbine design. Now, in terms of the long-haul engines that have a long nozzle also have a forced mixer, which is very effective not just for noise reduction but also for an addition in thrust. So those are the main measures that you can apply in order to reduce noise at the source, which is always the best solution. But then also, in addition to that, we have passive solutions, and the acoustic sound absorbers, the silencers, are placed in the entire upper area of the engine. They're very effective when it comes to reducing noise. They do reduce the noise at more than 10 dB, so reduce noise by more than half when it comes to noise perception. But this is not the end of it yet either. Technological advancements go further than that, and this is just a summary basically on this slide of the technologies that are going to be introduced in engines in the near and medium future. Of course, the bypass ratio is to be increased further, and therefore we'll then also be able to reduce the stream noise. The fan system is going to be optimized further. So this, in this context, we do not have used all the options we have. We can increase that ratio. We can also change the shapes of the blades in order to reduce noise overall. In addition to that, all the intake nacelle, so therefore, the nacelle will be optimized further in addition to what we've already done so far. So again, leading to further improvements. Now, when it comes to the sound absorbers, we've already heard the preceding speakers talk about that. There's also a lot of potential in that. The sound absorbers, the silencers that we can use, we can only use for a certain limited range of frequencies, and we are about to introduce those that can also be applied for broader frequencies. That is also for the combustor and the compressor ranges, and the variable nozzles. The previous speaker already talked about. This again increases the jet stream. The fan can operate at a lower speed, which again is better for the noise emission. So these were the measures that at this point in time we are working on quite intensively, and that are going to be introduced in the next generation of engines. But we need to take one step further. We now need to start working on the technologies that will be introduced after that. And one thing that's going to be very helpful is the ever-increasing option of using numeric methods, that is the high power computing methods. Those will make it possible for us to understand the sources of noise much better than we do so today. And in addition, we're also going to be able to compute the overall systems, thus being able to better assess the contribution, therefore also concluding better technologies in order to minimize noise. Now, another area is acoustic absorbers. So for the sound absorbers, there's even further potential in that they can absorb noise on a broader frequency, and so therefore the broadband noise that at this point in time cannot be absorbed as well will then be absorbed. As I said, today the range of frequencies is quite narrow. In addition, we're going to have passive as well as active systems. The active systems for fan, turbine, etc. Are still in the stage stage of research. They're not ready for operation yet, so that is why that will still take some time. The same holds true for active systems. So you generate a sound field that deletes another one, or sound surfaces that take an impact on other sources of noise. Again, a lot of research being done at DLR and other organizations that are quite promising, I have to admit, but again, also not at the stage of being used in actual operation. However, by 2050, there's still some years to go. So in the next year, or years or decade rather, a lot of progress is going to happen. And the same holds true for completely new aircraft configurations. So thinking of the propulsion aggregates that are then attached to the aircraft in order to reduce noise to an even greater extent. Now, these are the technologies of the future, and how do we approach this research work? Now, that's an X-noise chart from the European level, and this lists all the European research being done on this in order to make sure that we can do research into all these technologies. I'm not going to go through those projects step by step. I just wanted to illustrate to you that there are a lot of projects are ongoing, and with that, we are making sure that the next generation of engines will be quieter than the present ones. Now, these research projects are also supported by a lot of national projects in the respective European countries that I'm also not going to go into too much detail on either. I'd like to just take a few minutes to talk about something else. We already had talked about that. So going away from the turbofan, or not going away, but introducing an alternative system, the open rotor. Now, why do we look into that to begin with? Now, the background is that CO2 NOx and fuel reductions are part of the overall equation as well. And reducing fuel of a turbofan is physically limited because the diameter of the turbofans has to get bigger and bigger in order to effectively reduce fuel, and in order to have the even bigger nacelle, the friction on the surface again increases as well, and at some point you'll have a diameter that leads to the benefit inside the engine being lower than the overall benefit in fuel consumption. So this is what you can see up here. So the open rotor concept, so concepts that do not have a nacelle to begin with, promise a 10 to 15% additional fuel savings. Now, what about noise emissions? For 4 to 5 years now, 4 to 5 years ago, we started developing open rotor concepts. So for 4 or 5 years, we've been looking into this. Some of us might still remember the initial concepts that were introduced at the beginning of the 80s, end of the 80s, beginning of the 90s, that were relatively noisy. And I say relatively noisy because at the time they were not designed to take noise into account. Now, this time the development was quite different. All the stakeholders involved were aware of the fact that the open rotor concept, if it were to really gain hold and be successful on the market, has to be quieter than today's modern engines. And the latest research results, so intensive testing is being done together with Airbus and other stakeholders. So the intensive testing that we've done in spring have shown that the open rotor concept, designed to be low noise, is quieter than current engines in operation. So I believe it is an alternative concept. Now, the open rotor concept also will comply with the latest noise limitations. I also need to say that the turbofan technology is going to be reduced in terms of noise emissions further, and that you can see on the right-hand side. It's going to be less noisier than the open rotor, but at the cost of 10% additional fuel consumption, and therefore also CO2 emissions. So therefore, we will, and that we'll see in the future, have a discussion all around that. What do we want? Do we want to reduce noise, or do we reduce CO2 and NOx emissions? So that takes me to this slide, as again also previously shown in one way or another. As an engine manufacturer, I can only confirm that if today, and we obviously cooperate with the airline manufacturers very, very closely right from the start. Now, if we are to optimize an aircraft today, of course, safety is the uppermost criterion, no compromises in that regard. But everything else in terms of weight and cost, etc., when it comes to that, the environmental impact plays a key role, play a key role when it comes to optimizing these factors, and I'd say the other parameters have to suffer from that. Let me put it like that. I can only tell you, my marketing people come to my table and say, what can we do in order to make sure that the engine we currently have on offer will be even quieter without then compromising weight or cost too much. But I can say often enough, I have to just make them understand that cost and weight suffer from that. This is the market at the moment. If you want, if you can offer a quieter turbine, you have a benefit on the market. You have added value. Now, obviously, the questions being asked often enough, what will noise develop to be like in future? Now, when looking at an increase in air traffic, overall speaking, and this is something that some people in the UK came up with, they looked at traffic movements quite intensively. So, as part of the Sustainable Aviation Organization, and they looked at the output, or they depicted the result in a chart that you see here on the slide. And this is applicable to the UK only, and this is an average of all the airports in the UK. And they assume that starting from the year 2010 to the year 2050, air traffic movements will increase by 2% annually. So 2% annually, which means by the year 2050, air traffic will almost have doubled. Now, the red area shows you the current air traffic mix, or the fleet mix, all the known aircraft types, the numbers, movements, and noise levels we know. And you can also do your math and see how these aircraft will be discontinued in operation, which of course will take a number of years, sometimes even decades. These will be replaced by a newer generation of aircraft, and the group was divided into two categories: the imminent aircraft, so the first generation of aircraft, those that starting in 2007 went into service, and those that will then be operated until the year, launched until the year 2020. So the categories you see here: the A380, B747A, B340, BA787, then the 777 and the new version, the A320 Neo, and these are the aircraft of the future, and you already know their noise levels, roughly at least. And then you have a third category of aircraft, the so-called future aircraft, that will start service after the year 2020, and that will replace all those other two categories that you've seen previously. We took that as a basis and then looked at the noise level development starting from 2010 till the year 2050. Now, if you retained the current category of aircraft and did not replace those, there would be a continuous increase in noise. But because of introducing new aircraft types, you can see that in spite of air traffic increasing by 2% annually, the noise level on the ground remains constant with a slight decline. Now, this value assumes that aircraft is not are not optimized on not the noise basis, but also CO2. If you made noise the highest priority, which means if we use the Icana targets of 2050 and apply that, it would even lead to a reduction in noise in spite of the air traffic increase. So the yellow line did not take noise as the optimistic target, but a more limited improvement in noise emissions. Now, overall speaking, this shows that in spite of an increase in air traffic, we can assume noise level to remain the same or even be lowered in the vicinity of airports. And with that statement, let me also come to my conclusion. Now, in order to be able to achieve that, we of course need to invest a lot. And at Rolls-Royce, currently, about 2/3 of the overall investment scope and investment budget is addressing environmental targets, so fuel efficiency, NOx reduction, CO2 reduction, and also noise level reductions. So noise and emissions are two main driving factors for new engine concepts. Engines today will look very different if we didn't have these targets, and this is going to be emphasized further in future. Low noise technologies and emission reduction technologies will continue to determine design more and more so in future. On the other side, however, you also have to see that if you wanted to introduce revolutionary technologies, they're always associated with risks as well. And what that means is that you have to invest a lot of money, do a lot of research, and a company also has to be competitive at the end of the day. Because if you're not competitive, then of course you also do not have the possibility of really influencing the market, for instance, in the sense of noise reduction. That is a fact just as well. And no company can do this alone. That is why we're going back to the concerted efforts. So cooperation is key in this, which is what we're doing already, but we also need support by the policymakers, the regulatory authorities, but also the research organizations like DLR, etc., you name them, and also the many universities there are in this world that do research in this context. But there is one thing that remains for sure. Rolls-Royce is going to continue to keep up its high efforts in order to further reduce environmental noise. And on behalf of Rolls-Royce, this is what we believe. But I think our competitors just do the same thing, and therefore we can rest assured that we'll have quieter aircraft available in future. Now, thank you very much for your kind attention, and looking forward to your questions. Thank you very much, Mr. Holste. And just
and the decoupling of aviation from noise is really a perspective we should follow on. So thank you very much for the presentation, and I just can tell you that DLR will always be ready to support you with research, but also through our project management office with money. Okay, now some questions or remarks from your sides, please. Indicate your name and raise the question or give the comment.
Klaus Wenig aus Frankfurt.
Professor Nick from Frankfurt. Mr. Holste, in the study you quoted, a sustainable aviation report that is, are there also any findings on the NOx and CO2 values as well? You obviously concentrated on noise, but does the study also have some information about CO2 and noise and NOx? I'm sorry. Unfortunately, I'm not active in this group. My colleagues in the UK that are in the noise group are doing that. Andrew Campton is active in that organization, and I have to admit that I don't have any figures for those two categories. I talked to Mr. Kempton and I read the report, but I'm not active in the group.
Next question. We have some time, so don't hesitate. It's a good opportunity. Please, over there. again indicate your name and...
Achim.
Achim Heppert, Frankfurt Airport Magazine. So for the moment, we have kerosene as the type of fuel for aircraft. This doesn't have to remain the case in the next 50 years. Will the engines have to remain the same, or will they have to be changed and you'd have to develop new ones? Now, I mean, in principle, other types of fuel can be burned in the combustion chamber. So the biofuel concept, for instance, or other ideas might change the combustor a little bit, but it is doable. You know, the nozzles and the control mechanisms would have to be altered, but as I said, you know, it does mean additional research, additional investment, not as simple as it might have sounded, but I think it would be doable.
Possibility to tell you a little bit strange story. If you are using synthetic fuels right now, then you have a very strange problem, because the fuel is very well defined on the basis of kerosene. So if you have a synthetic fuel, you will not meet all the requirements, but not in the wrong in a bad direction, but in the good direction. That means you are better than the kerosene, which is defined very well, and therefore we need also new regulations for synthetic fuels, because they are better and not because they are worse. So that's an interesting point. So, but of course, the price is also an important aspect on that, in that respect. However, we'll see. And I mentioned also electric propulsion in the very far future. Further questions? Please, over there, the final one. Mike in the last row. Somebody? Okay.
Thank you, Kieran Byrne, Fingal County Council. Can you tell me, what impact do you think a elimination or reduction in the kerosene tax exemption would have on research and development in the industry?
Sorry, I did not.
You did not get, okay. Was wäre der Einfluss oder was ist der Einfluss von der Steuer, der Kerosinsteuer, auf die Entwicklung der Triebwerke? Das ist das, was ich verstanden habe. Ich hoffe, einige haben das genauso verstanden. Das war mein Verständnis.
Yeah, that was my understanding. What's the impact of the kerosene tax on the research and development in engines and turbines? Now, the higher fuel cost, you know, that's just pure mathematics. If kerosene costs increase, the trend will be to develop even more efficient engines.
And the airlines are looking just on the fuel consumption and not any longer on the noise. I think this was behind your question. I don't know, but maybe it was. It was. Okay, that was the main focus.
If this is a question, no, of course not. Noise is, as I have mentioned, a pretty important parameter in the optimization design, because we all are aware an increase of the aircraft traffic can only be done if we are able to produce lower noise aircrafts, and especially for us, produce low noise aircraft power plants.
Okay, thank you very much for this. We will now come to the next presentation. Thank you very much to you, Mr. Holste.